So today is November 9th, and we are doing the test 3.1 review. So your test is tomorrow. That is the first test of the third 6 weeks. So on this first section, we are factoring each completely. And so when we factor, we are just trying to pull out what is common. So we haven't gotten into full-on factoring yet, but we are pulling out the greatest common factors in this first section. So in 2x squared and 8x, so the answers to the odds are posted, so I'll be doing the evens. So on 5n cubed minus 15n squared, what's in common, we can think of what can I divide both of these by. So what's the greatest number that I can divide 5 and 15 by? And that number is 5. And then whenever we're taking out a variable, we're going to take the smallest power of the variable out. So the smallest power that I see is n squared. So we're taking out 5n squared. And then what's left over is whatever I need to multiply 5n squared by to get to 5n cubed. So to get to 5n cubed, I would need another n. And then to get to negative 15, I would need a negative 3. To get to n squared, I would just need 1, so n minus 3 stays in there, and that is factored completely. We'll do the same thing on number 4. So we have k cubed minus 9k squared. I'm going to pull out the GCF. So with our coefficients, we don't have a number that we can see in the front of k cubed, so it is a 1. So the common number between 1 and 9 is 1, which we don't have to write. And then k cubed minus 9k squared, so now we're looking at the variable k. We're going to take out the smallest power between the two. So the smallest power between cubed and squared is a square. And so to get to k squared to k cubed, I would still need a k. To get to negative 9k squared, I would still need a 9. And then that k squared is already in there. Now on the next section, we're sketching the graph for each function and we're listing the transformations from the parent function. So from my parent function, which is y equals x squared. So this is in vertex form. Which is y equals a x minus h squared plus k. So we have all of our transformations written in there. So I'm going to list my transformations first. First thing that I see is that I don't have a new a value. There's not one in the front. So I am not going to have any reflections, any dilations. So then on the inside, I have plus 1, which we know is the opposite. So we're moving horizontally to the left 1 unit. And then on the end there we have that minus 4, which we take it as it is. And minus 4 would take me vertically down 4 units. So we're going to take our parent function, which normally starts at 0, 0, left 1 unit, and down 4 units. So normally we would start here in the center, but we're not going to start there. I'm going to go left 1, down 4. And I know that my axis of symmetry will cut through that vertex. My a value would be here. Since I don't see it, a is 1, which is positive, so this should be facing up. And I just need 2 more points, so I can plug in any numbers. I'm going to plug in a 0 and a 1, so I can work with that right side of the parabola. So at x equals 0, let's see what y is. Y would equal 0 plus 1 squared minus 4. 0 plus 1 is 1, so 1 squared minus 4. 1 squared is 1. Oops. 1 squared is 1, so we have 1 minus 4, which is negative 3. So that gives me the point 0, negative 3. So we'll go to 0 and negative 3. And then let's look at when x equals 1. We have y equals 1 plus 1 squared minus 4, which is 2 squared minus 4, which is 4 minus 4, and that's 0. So we would have a point 1, 0. So at 1, we're on 0 on the y-axis. So this is the right side of my parabola. And then remember that axis of symmetry is cutting it in half, so we can reflect to the other side. So we've got a point here, and then here. And then we connect those and make our parabola. So now we're going to do the same thing on number 8. We're going to list our transformations first. Again, I don't have an a value, so that means a is 1. There's not something in the front of there, and so we don't have any reflections or any dilations. But I have something on the inside. It's a plus 3, so we're going to think opposite. So we have a horizontal shift left 3 units. And then we have plus 2 on the end. We take it as it is. We have a vertical shift up 2 units. So from 0, 0, we're moving left 3 units and up 2. So left 3 and up 2. Pay attention to where your axes are, because this is not right in the center like we're used to. My axis of symmetry will cut through that point. And the axis of symmetry helps us so that we don't have to find 4 different points. We can just find 2 and then reflect. So then we're going to find the other 2 points that we're going to use. I'm going to work on the right side since those are smaller values. I'm going to use negative 2 and negative 1. So at x equals negative 2, y would equal negative 2 plus 3 squared plus 2. So y would equal negative 2 plus 3 is 1 squared plus 2, which is 1 plus 2, which is 3. So we would have a point negative 2, 3. So negative 2 goes up to 3. And then we're going to find the point for negative 1. So at x equals negative 1, let's find what my y value is. Y equals negative 1 plus 3 squared plus 2. Negative 1 plus 3 is 2. So 2 squared plus 2, 2 squared is 4. 4 plus 2, which is 6. So we have a point, negative 1, 6. So that's the right side of my parabola. It is facing up because, again, this is a equals 1. It's positive. And so I'm going to reflect across that axis of symmetry to get the left side, and then connect those points. Okay, so on the next section, we're finding the discriminant, and then we're going to state the number and type of solutions. So just a quick refresher, remember that if D, our discriminant, is greater than 0, so some number that is positive, we will have one root, and it is real. If D is equal to 0, we will have one root that is real. And if d is less than 0 or a negative number, then we will have two roots. They are imaginary. The only thing that is a little special is that if we have a perfect square, so this is for not a perfect square. If we have a perfect square, which we should know our perfect squares, they're like 4, 16, 25, 36, numbers that we can take a square root and get a good clean number out of. So if we get a perfect square, then we have two roots that are real. So let's find our discriminant. Remember to find the discriminant. D equals b squared minus 4 AC. And we do have to make sure that we make it equal 0 first. So on number 10, I'm going to move everything over so that way it can equal 0. Negative 7a squared plus a, and then I'm going to add 8 over, and I get plus 0 equals 0. So a is negative 7, b is 1, and c is 0. I'm going to plug those numbers into my formula for the discriminant and then see what type of solutions and the number of solutions that I have. So my discriminant d equals b squared 1 squared minus 4 times a times c. Uh-oh, I see something times 0, so that knocks out. D equals 1 squared, which is 1. So 1 is a tricky number because it is a perfect square. 1 times 1 is 1. So we have a perfect square, which means we have two roots, and they are real roots, meaning they're real numbers, not imaginary numbers, which we'll get into later. On number 12, we're going to do the same thing. We're going to move that 8 over, that negative 8 over, so we can have equals 0 first. We have 3a squared plus 7a plus 7 equals 0. Now that it equals 0, I'm going to solve for d. So d equals b squared, which is, let me write those out first. A is the first number, so 3. B is the second number. C is the last. So d equals b squared, 7 squared, minus 4 times a times c. So 7 squared is 49. 49 minus, 12 times 7. 49 minus 12 times 7, I believe, is 84. I could be wrong. D equals 49 minus 84. I know that's going to be a negative number. I don't have to find that exact number because it's only asking for the number of solutions and type of solutions. But let's find what 49 minus 84 is. It's negative 35. So D is less than 0, which means that I have two roots that are imaginary. Now on the next one, it says, sketch the graph of each function, list the vertex and the axis of symmetry, then find the domain and range. So vertex, axis of symmetry, domain, and range. But what do we know about the domain of our quadratics? Yep, it never changes. So it's always going to be all real numbers, or negative infinity to positive infinity. So we're going to find our vertex and our axis of symmetry first. So with this y equals 2x squared plus 8x minus 12, I need to find my vertex, which is negative b over 2a. Sorry, my dog wants to leave. Okay, so we're finding the vertex using negative b over 2a, and then remember after we find this is the axis of symmetry. The axis of symmetry, and then after we find the axis of symmetry, we plug that in to get the vertex. So I'm going to write out what my a and my b are. A is the first number, b is the second, and then c, let's just get used to writing it, is 11 because it's the last number. So for my axis of symmetry, we would get x equals negative b, so negative 8 over 2a, so 2 times 2. Negative 8 over 4, which is negative 2. So when we have negative 2 for x, that's going to be that straight up and down line that cuts our parabola in half. So my axis of symmetry is x equals negative 2. Then my vertex, I'm going to plug that value in to the equation. So y equals 2 times negative 2 squared plus 8 times negative 2 plus 11. So negative 2 squared is going to give us 4. 2 times 4 is 8 plus 8 times negative 2, so minus 16 plus 11. That gives me 19 minus 16, which is 3. So the y value of my vertex is 3, so it's negative 2, comma 3. So right here. And then we need to find the domain and the range. So vertex is negative 2, 3. Domain, all real numbers, negative infinity to positive infinity. This is a positive a, so it's facing up. So for my range, my vertex will be a minimum, and it's going to go up to a number. Sorry, it's going to go down to a number and up to infinity. So my lowest value is the y value of the vertex, and then it goes toward infinity. I'm going to do a rough sketch. So I'm just going to, I'm not doing accurate, so let me, a little disclaimer, not an accurate graph. But we did find an accurate axis of symmetry and vertex, and then we found our domain and our range. We'll do the same thing on number 16, but now we're dealing with vertex form. So we still need to find the axis of symmetry, the vertex, domain, and range. Now when we're in vertex form, we get our vertex from right here. So my vertex is going to be opposite of what's on the inside, so negative 1, outside as it is, positive 2. So negative 1, positive 2 is my vertex. I'm facing up because that's positive. My domain never changes. And then my range depends on that vertex. So since we're facing up, that is a minimum point. So that's my lowest value on the y's. And then it's going to go up toward infinity. And then my axis of symmetry is going to cut through that vertex. So the x value is my axis of symmetry. And then again, just for time's sake, I'm not going to make this an accurate graph, but we do know that it is opening up. So again, not an accurate graph. But we did find all the components that they asked for. Number 18, y equals 3 times x plus 2 squared plus 4. Again, we are in vertex form, so we'll find our vertex from those two numbers right there. Opposite of what's inside, so -2, the end as it is. My axis of symmetry cuts through, so it's the x value, of the vertex. So I'm at -2, 4. That's my axis of symmetry. And then domain and range. Domain will not change. Range depends on our vertex. This is a positive a value. So our graph is positive, facing up, which means our vertex is a minimum point. So that is the lowest y value that I can hit, and everything else will be greater than that. So we're going to take that y value, 4, and then we're going to go toward infinity. I am going to make number 18 an accurate graph just so we can see once again the process of finding our points. So I'm going to find any 2 points and then I'll reflect them. I see that I don't really want to work with negatives, so I'm going to work with the positive values. I'm going to use 0 and 2. So at x equals 0, I'm going to plug that into my y's. So y equals 3 times 0 plus 2 squared plus 4. Y equals 0 plus 2 is 2, so I have 3 times 2 squared. I'll write out all the steps, plus 4. 3 times 4 plus 4, which is 12 plus 4, which is 16. So that means I have a point 0, 16. So there's my other point. And I see that any further is going to get off of the graph, so I'm just going to find that one point and then reflect it across. And I've got a super skinny graph, and the reason it's skinny is because this made a vertical stretch. So we can actually see that happening in our graph. So that is a more accurate sketch than the ones before, just so you can see again how to find those other points. So then the remainder of the review is for you to do, but the answers are posted so that way you can check. We are checking for work on the review when you turn it in, but again, the answers are there just so you are aware, and so that if you do need help, you can look back to those and check if you were correct. So make sure that you get the review completed, and then good luck on your test.